Hey guys, Mr. T here. This is another video. This one is on the solutions to the motion questions 01 sheet for year 10 physics test revision. So again, speed, velocity, acceleration problems. So we're going to be using the formula: speed is equal to distance over time, velocity is equal to displacement over time, and acceleration is equal to the final velocity or final speed minus the initial speed or velocity over the time it took to get between those two. So question 1, Pete is driving down 7th Street. He drives 150 meters in 18 seconds. What's his speed? So it's looking for the speed, remembering your little triangle if you prefer this. Speed is equal to distance over time. So from the triangle, cover up speed and it tells you its distance over time. The distance he travelled was 150 meters and it took 18 seconds. So it's going to be, if you use your calculator, 8.33 meters per second. A person jogs 4 kilometers in 32 minutes, 2 kilometers in 22 minutes, and 1 kilometer in 16 minutes. What's the jogger's average speed? So we already saw from before, speed is equal to distance over time, so I'm going to leave that there. So there's 3 different speeds here, and it's asking to find the average speed. So let's find the 3 different speeds and average them out by adding the 3 together and dividing by 3. So the first speed was 4 kilometers in 32 minutes, which comes to 0.125 kilometers per minute, because remembering the time was in minutes. The second speed was 2 kilometers in 22 minutes. And if you use your calculator, that comes to 0.09 kilometers per minute. And the last one was 1 in 16 minutes, and that comes to 0.0625 kilometers per minute. So the average speed is going to be the 3 of them, 0.125 plus 0.09 plus 0.0625, divided by how many numbers I added together, which was 3 of them, and that comes to 0.0925 kilometers every minute average speed. A train travels 120 kilometers in 2 hours and 30 minutes. What's its average speed? So I was looking for the speed, which is distance over time. 2 hours and 30 minutes. We can't write 2.30 because 30 minutes is not 0.30 of an hour. How do you work out what the fraction is? 30 divided by 60, because there's 60 minutes in an hour, and that comes to 0.5. So 2 hours 30 minutes is 2.5 hours. So the distance was 120, and it took 2.5 hours. 120 kilometers, sorry. 120 divided by 2.5 comes to 48 kilometers per hour, because the units were kilometers and hours. A plane's average speed between 2 cities is 600 kilometers an hour. We know the speed. If the trip takes 2.5 hours, how far does the plane fly? So we've got the triangle, and this time we're asked for how far does the plane fly, so we're looking for the distance. So distance is going to be s times by t. The speed was 600 kilometers an hour, times by the time, which was 2.5 hours. That comes to 600 times by 2.5, 1,500 kilometers. George walks to a friend's house. He walks 750 meters north. He realizes he walked too far. He turns around and walks 250 meters south. The entire walk takes him 13 seconds. What's his speed? So remember, speed is equal to the distance over the time. The total distance he traveled was 750 north and the 250 south. It took him 13 seconds. He walked a kilometer, 1,000 meters in 13 seconds. That's ridiculous, but whatever, we'll go with this. 1,000 divided by 13 seconds. That comes to 76.92 meters per second, which is ridiculous. But that's the question, and that's what we'll answer. Now, in problem 5, what was George's velocity in meters per second? He didn't draw a picture to find his displacement. So velocity is displacement over time, and let's draw a picture. He went 750, but then he went back 250. So really he's gone 500 away from his starting point. So his velocity is going to be 500 divided by 13 seconds, which comes to 38.46 meters per second, which is still ridiculous, but that's what the question is, and we'll answer it. 7. A roller coaster's velocity at the top of a hill is 10 meters per second. 2 seconds later, reach the bottom of the hill at 26 meters per second. What's the acceleration of the coaster? So, the triangle for that, acceleration, and its change in velocity, which is final velocity minus the initial velocity. So remembering that, we're looking for the acceleration. So acceleration is going to be final velocity minus initial velocity divided by the time. It gets to the bottom at 26, so it ended up at 26, minus, it started off at 10, divided by 2 seconds. 26 take 10, it's going to be 16 over 2. 16 divided by 2 is 8. And let's think about the units we were using. So these top two were meters per second, this was seconds, so meters per second over second, so it's going to be meters per second per second. You may notice in some places it says meters per second to the negative 2. These are exactly the same thing. Okay. Next, number 8, a roller coaster moving at 25 meters per second at the bottom of a hill. 3 seconds later, it reaches the top of the hill, moving at 10, so it slowed down. What was the acceleration of the coaster? So from the previous question, acceleration is equal to v final minus v initial over the time it took. V final was 10 meters per second, and v initial was 25 meters per second, and it took 3 seconds. 10 take 25 is going to be negative 15 meters per second divided by 3 seconds. It's going to be negative 5 meters per second per second. So it was a deceleration, therefore deceleration, because it was a negative number. A car travelling at 15 meters per second starts to decelerate steadily. It comes to a complete stop in 10 seconds. What is its acceleration? So acceleration again is equal to v final minus v initial over the time. It was going at 15 and it decelerated to a complete stop. So a stop is 0. So it finished off at 0. It started at 15. It took 10 seconds. 0 minus 15 is negative 15 on 10, which comes to negative 1.5 meters per second per second. That's deceleration again. Why? Because it's negative. A child drops a ball from the window. The ball strikes the ground in 3 seconds. What's the velocity of the ball the instant before it hits the ground? So this looks like there's not enough information, but we've spoken about gravity. Everything on Earth is accelerating towards the center of the Earth at 9.8 meters per second per second. Now the acceleration triangle tells you change in velocity, acceleration, and time on the bottom. Here it's asking what's the velocity of the ball the instant before it hits the ground. So it's actually asking for the final velocity. So if we're looking for velocities at the top, it's going to be acceleration times by the time. And the change velocity is Vf minus Vi. That's what that is equal to the acceleration times by the time. Vf is what we're looking for. The V initial, if you're dropping a ball from a window, it started off at 0 velocity. The acceleration was 9.8, and it took 3 seconds. So let's work out what we do know. Vf take 0 is still going to be Vf, so leave the left-hand side as it is. 9.8 times by 3 is going to be 29.4. So the velocity before the ball hits the ground is going to be 29.4 meters per second. A boy throws a ball straight up into the air. It reaches the high point of its flight after 4 seconds. How fast was the ball going when it left the boy's hand? So again, how fast? It took 4 seconds, and it's like you're probably looking for an acceleration. But again, there's an acceleration when you're throwing. Its gravity is 9.8 meters per second towards the ground. He's throwing it up, so gravity's acting in the opposite direction, so I'll make it negative here. So it's looking for how fast the ball when it left the boy's hand. So this time we're looking for Vi. How fast was it going when it left his hand right at the instant he threw it? So we know Vf. At the highest point of its flight, the ball has stopped moving for a moment. So at the top of its flight, Vf is 0, and you're taking away the initial velocity, which we don't know, is equal to the acceleration, 9.8, negative 9.8, because it's pulling the ball towards the ground, times by a time of 4 seconds. Let's work out what we do know. We don't know what 0 take Vi is going to be, but negative 9.8 times by 4 is going to be negative 39.2. I want to get rid of the 0 from the left-hand side. The opposite of adding 0 to something is taking 0. So if I took 0 from both sides, I'd be left with negative Vi is equal to negative 39.2. And if negative Vi is negative 39.2, then Vi must be 39.2 meters per second. So that's the speed of the ball when it left the boy's hand. A train moves from rest to a speed of 25 meters per second in 30 seconds. What's its acceleration? So acceleration is Vf minus Vi on t. It got to a speed of 25, so it was 25 minus, it was at rest, so it started off at 0, and it took 30 seconds. 25 takes 0 is 25 on 30. 25 divided by 30 is 0.83 meters per second. Alright, if a train is going 60 meters per second, hits the brakes, and it takes a minute 25 seconds to stop, what's the train's acceleration? So we need to deal with 1 minute 25 seconds first, because we can't put 1.25. 25 seconds as a fraction of a minute is going to be 25 divided by 60. So 25 divided by 60 is going to be, just grab the calculator again, 25 divided by 60, 0.42. So 1 minute 25 seconds is 1.42 minutes. So the acceleration, it was going at 60, hits the brakes and it stops, so it finished off at 0. It was going at 60 meters per second over the time of 1.42 minutes. 0 takes 60 is negative 60 on 1.42. Remember, negative 60 is meters per second, and this bottom one is in minutes right now. Negative 60 divided by 1.42 is negative 42.25 meters per second per minute. Now there's another way that you could do this. I'll do it in a different color, hopefully, if I can work out how to get pencil. If you did it all in seconds, so 0 takes 60 on 1 minute 25 seconds is 85 seconds. So you would have negative 60 on 85. Negative 60 divided by 85 is going to be negative 0.71 meters per second, and now it's per second. How long will it take a car to go from a complete stop to 44 kilometers an hour if accelerating at 5 kilometers an hour? This hour squared means kilometers per hour, just like meters per second squared is meters S2 is going to be meters per second. How long would it take a car from go to complete stop if they're accelerating? So we know the acceleration, so use the little triangle. Acceleration times by time, change in velocity. How long? So we're looking for the time. So time is going to be Vf minus Vi on the acceleration. It started off at a stop, it got to 44 kilometers an hour. Take 0, which was the initial speed, over 5 kilometers an hour. So it's going to be 44 kilometers an hour over 5 kilometers an hour per hour. 44 divided by 5 is 8.8. So this car's accelerating extremely slowly. So that's another unrealistic one, but all we can do is use the question information. How long will it take a car to accelerate from 15.2 meters per second to 23.5 meters per second if it's got an acceleration 3.2? So these are your triangle, change in V, A times by T. How long? So we're looking for the time again. So time is going to be the change in V, which is Vf minus Vi on the acceleration. It went from 15.2 to 23.5, so it's finished up at 23.5. It started off at 15.2 divided by the acceleration of 3.2. 23.5 take 15.2 is 23.5 take 15.2, 8.3 on the top line over 3.2. So 8.3 divided by 3.2 is 2.59. Now let's review what these units were. This was in meters per second, 3.2 meters per second, so we're all in meters per second and seconds, so it's 2.59 seconds to accelerate from 15.2 to 23.5. So just checking if there's any further questions. No, that sheet's done. Alright, so hopefully that video helps you out, and I'll see you in the next video.